Okay, so we're going to go ahead and skip one section so we can learn the basic differentiation rules, the derivative shortcut rules, and then we'll come back to it, but this just saves you a lot of time. So we're going to do the constant rule, the power rule, and then basic sine and cosine. And you'll be using the power rule a lot because we'll be able to use those in applications. So for a constant function like f of x equals 5, remember it's a horizontal line at 5, and a derivative means slope, so the slope of that line is 0, so the derivative of a constant number is always 0. Okay? Now, if we don't remember that, then we can actually use the next rule, which is called the power rule. So this is x raised to any power. The way you find the derivative is you're going to bring the power down in front. It's going to be multiplied. And then we want to subtract 1 from the exponent. Okay? So anytime you can rewrite functions as powers, you want to. So then you can use the power rule. So let's look at 3 quick examples. So for our derivative, get used to writing your notation, especially on your homework. This just clarifies your work. So since this is just x to a power, I can use the power rule. We'll bring that 5 down and then subtract 1 and we get 4th. And that's it. Now this, you can't just do it in a denominator. You need to rewrite this. So remember, if it is in a denominator, you can rewrite that using negative exponents. So now our derivative, we can use the power rule. So bring the negative 2 down. And then if you subtract 1, please be careful, you get negative 3. Now, typically, we don't like to leave negatives in the answers. If this is a free response question, you're welcome to do that. But the negative 2, and then we need to bring, that has a negative exponent, so that's the only term that gets brought down. So you have to remember a lot of the exponent properties, okay? Like I said, after this unit, your math, you're going to remember a lot of things that you've learned over the years, and this is why. So example 3, this is a rational exponent. You have to remember it's always x to the power over root. So I think that's from secondary 2. So the power is 2 and the root is 3. So you have to remember this. So then when you go to take the derivative, you'll bring the power down in front. And then if you subtract 1, 2/3 minus 1 is negative 1/3. And remember, try to do these without calculators because you would not be allowed to use one on the AP exam. This could be multiple choice or free response. Write your answer with positive exponents. The x goes down in the denominator. Okay, so that's the best answer. All right, now sometimes though you get numbers that are being added in with multiplication. And so that's the constant multiple rule. So basically what it says is you can keep that constant in front and perform the derivative, just keep multiplying. So on this, we're going to use the power rule because it is x to a power. That's being multiplied. So when you go to take your derivative, when you bring this down, you multiply by the coefficient that's already there. So 2 times 3 is 6, and you still subtract 1. And that's it. Same thing here, you need to rewrite this as a power. So this would be to the negative first power. So our derivative, we're going to bring this down with multiplication, and then subtract 1. Remember, this is a number, so that's going to stay negative, and I always put the 2 in front. I always put my negatives in front, and then my x goes in my denominator. So this is the best answer. All right, last one. Rewrite this original, so power over root. So our derivative, you've got 3/5 times 3, you just multiply the numerators, so 9/5, and subtract 1. And rewrite this, we've got 9/5, and that x goes in the denominator. Okay? The sum and difference is no different than the limits. It basically means you can take each power separately, whether you add or subtract. So we're going to do the power rule 1, 2, and we'll really do it here. So you can think of this as being x to the 0 power if you forget that the derivative of constant is 0. So our power rule derivative says bring the 3 down, subtract 1, bring the 2 down, subtract 1, and if I bring this down, I'm going to get 0. So if you remember that, then you would stop right here. Okay? This one, I want to rewrite this before I start. Okay? So now we're ready for the power rule. So bring down and multiply, subtract 1. Bring down and multiply, subtract 1. And bring down and subtract 1. Okay? Rewrite. It's really up to you, but you would be matching this on multiple choice. This is not usually a free response question. So the rule is typically if they have fractions in the beginning function, then they'll have fractions in the ending function. They don't leave it as a negative exponent. Okay? All right, now these you're going to have to memorize. So the derivative of sine and cosine, there's a lot of proofs out there, but this video is already going to be long enough, so I'd like to just tell you the rule and have you memorize it. So the derivative of sine is cosine. Okay, notice this has to be just x. When it gets more complicated, we're going to have a different rule that we need to use. And the derivative of cosine is negative sine. Okay, so you have to remember that negative. When we're multiplying, it still applies. So I'm ready to take the derivative. Now, this isn't a power rule, so we're going to bring the 2 down, and we just need to find the derivative of sine. Well, the derivative is cosine. So it'd be 2 cosine x. Same thing here. We're going to bring that 1/2, and the derivative of sine is cosine. All right. Remember, this is like x to the first, so we can bring the power down. And then when we subtract 1, we get 1x to the 0. We'll clean that up in a minute. The derivative of cosine is negative sine, which is going to look like subtraction sign. Well, x to the 0 is 1, so our derivative is equal to 1 minus sine. You just take them separately because they were being added and subtracted. All right, so horizontal tangent lines. Horizontal tangent lines we will do a lot of applications because if you think of a tangent line, remember tangent was AKA for slope derivative. And so when we have a horizontal slope, that has a lot of applications, and you might not realize what they are yet. But you can find where a function has a horizontal tangent line by taking the derivative of the function and setting the derivative equal to 0. And typically you want to solve this, okay? You won't know why we're doing this, but we'll get to the uses later. So, number 1, for what values of x do the following functions have a horizontal tangent line? So you have to think, oh, tangent is my derivative, and horizontal means my slope is 0. So this is what you should be thinking when you start reading directions. That's kind of how calculus will go, and that's always the hardest part for students. They're like, well, if they would just tell me what they're looking for, then I would know what to do. But that is part of you getting better at reading the directions and instructions, okay? So we're going to start by taking the derivative. So use a power rule, multiply, subtract 1, multiply. I'm going to take a power off, so my x's are going to go away. And then remember, the derivative of a constant is 0. So 6x minus 2 is my entire derivative. So now if I want to find my horizontal tangent line, we're going to set our slope equal to 0 and set it equal to our general derivative, okay? So add 2 and divide by 6. Now, you should still reduce because we always reduce. So at x equals 1/3, there would be a horizontal tangent line. And you don't need to find the y value because it just says values of x. If it would say find the points, then you would need to find the ordered pair. Okay, so also pay attention to the directions for how the answer is. All right, we're going to do some trig. So this is like a -1. So I'm going to leave that -1. And the derivative of cosine is negative sine. So if we clean this up, negative times negative is positive sine x, okay? So we want to know, when does sine equal 0? So you have to remember, without any calculators, that 0, pi, 2 pi, it's going to be every pi, positive and negative. So x equals, we've got every pi times n, where n is all real numbers. It's really going to be our integers. Okay? Which is actually, I believe it's z. All right. So those are the basics. Try your power rules and your trig derivatives and see how you do, okay? Good luck.